The supporting tools of the drill press. This module will describe and explain the various support tools used with the drill press. Supporting tools are to a drill press what a blade is to a razor. The most expensive and complex drill press can do no better job than the supporting tools will allow. A dull drill will produce a ragged hole, and a bad holding device will permit the work to slip from under the best drill in the world. The most frequently used supporting tool is the twist drill. They come in various sizes which are designated by numbers, letters, and fractions. The size of the individual drill is marked on the shank, with the exception of very small drills where a mark would be too small to be easily visible. In this case, a micrometer may be used to determine the size. Drills this small are usually stored in special sets or holders. Another popular supporting tool used with the drill press is the countersinking tool. It is a cone-shaped cutting tool that is most often used to provide a seat for a flathead screw, so that the head of the screw will be flush with the surface. When it is necessary to put a Philister head screw or a bolt in a hole so the head will be flush with the surface, a special cutter called a counterbore is used to enlarge enough of the hole to allow for the head to seat flush with the surface. Some counterboring tools are manufactured with pilots or guides, which go into the holes ahead of the cutter and provide an axis for the tool. This ensures the accuracy of the bore so that it will be concentric with the hole. There are also counterbores with an 82-degree included angle cutting edge for use with flathead machine screws. Counterbores are often referred to as spot-facing tools. Spot-facing means to take light cuts across the face of the hole. This is done to square up a surface and furnish a seat for a washer, the head of a bolt, or a nut. This tool has a pilot that can be removed and one of a different size put in its place. You won't run across this one every day in the week, but you should be able to recognize it when you see it. It's a core drill. When castings and forgings are made, where the finished product calls for holes, rough holes are put in the casting or forging to save metal and time. A core drill is used to enlarge the cast hole. The core drill does nearly all its cutting on the chamfered edge. Don't ever try to drill a hole with a core drill. The cutting edges don't go to the center. Drilled holes are not always accurate enough where machining requirements are very precise. When this situation occurs, the hole must be brought to size by a reamer. Always use a machine reamer in the drill press. Never use a hand reamer. The reamer is a secondary operation tool because it must be used in a hole that has already been drilled or bored. This supporting tool should be familiar to you, but in case it isn't, it's a tap. Taps, like reamers, can only be used in previously drilled, reamed, or bored holes. Taps provide the internal or female thread for such holes. These two devices have no resemblance to each other, but they still have something very much in common. They're both holding devices. One is a vise, and the other is a taper sleeve. The taper inside the spindle holds or secures the taper shank drill in the drill press. The vise secures the workpiece in place so it can be drilled, bored, or whatever is necessary. There are two groups of holding devices, one for the cutter, the other for the workpiece. This is a key-type drill chuck. This is the kind of chuck that is usually used with small drills that are 1/2 inch in diameter or smaller. They are designed for straight shank drills. Sometimes the tapered hole in the spindle is too large for the tapered shank of the drill. When this happens, a machinist will use sleeves to increase the size of the taper on the drill so it will fit the spindle. A drill drift is used to remove tapered objects from the spindle of the drill press, or to separate taper sleeves. Many drill presses do not have a reverse mechanism, so without this tapping attachment, you could not do a tapping operation on the sensitive drill press. The vise and set of parallels you see here are examples of work-holding devices. Such devices are of vital importance. Without them, the work can slip and be of poor quality, or worse, fly off the table and cause severe injury to the operator or others. There is more to a set of parallels than a casual observance would disclose. They are bars which are accurately ground, and they're designed to raise the workpiece high enough to drill through it without damaging the work table or the holding device. This is a T-bolt. In nearly all drill press tables, you will see slots. These are known as T-slots. When the T-bolts are inserted in the slots and tightened, they secure the other work-holding devices. Here you see an assortment of clamps. When you have to mount work on a drill press table, you'll find that an assortment like this will be very handy to have. These are not toys for children, although they may look interesting enough to be. Actually, they are setup blocks. They can be adjusted to set up almost any size of workpiece. The jack screw and angle plate you see here are more work-supporting devices. The jack screw is adjustable for different setups, and the angle plate can be clamped or bolted to the table and the workpiece secured to it. Drilling a workpiece that is round can be troublesome. This V-block and clamp makes it a lot easier. They are made in different sizes to accommodate different diameters of workpieces. The knowledge and proper application of the drill press is an important part of the drilling operation. No machine operator can consider himself proficient in his trade until he has a thorough understanding of them.